Okay. So when the user looks at the awkward arrays from the Python side, you can just ask from buffers of this array to actually symmetrically either to request the buffers of the array and description, and then put it from buffers to create an awkward array, and the same from Julia's side. So if we take a simple array like that, for example, which is just a list of lists, the form of this array is going to be that which has content, offsets, and then we can just construct. So for this particular module, we have tried PyJulia and PyCall, which actually allows us to do this round tripping. Okay, I'm going backwards. So the first question as a novice, I asked, why PyJulia latest release of 0.6.1, and is it PyJulia a PyCall right decision, actually right direction? And thanks to Chris, we discussed it, yes. The answer is that Python call and Julia call is a better choice. So we'll go with that. For the user, just using these two buffers is probably a little bit awkward because you get all this dictionary of arrays and JSON form. So we want to make it a little bit more user-friendly and have a function which just, you put the array, the Julia array in, where is it? Here? And you get Python object, which is awkward array. And then you can do actually Python operations, awkward operations on the awkward array in Julia. How the inside of this function would look like, we need to do the same. We take the buffer, construct buffers from the array. Actually, this is no copy operation. So it's just, you have the memory of awkward array, you just point to it, and you say, this is how it looks like. One little thing I haven't found out, because this is creates a dictionary in Julia. We need to make a NumPy array of that, because actually the awkward from buffers takes the byte array. So the question here is who actually owns the memory? Because we have data, we have access from Python, we have access from Julia. So this is something to look at. And naively, I just check, okay, what is the data of Julia array? What is the data of Python array? Looks the same. PyCall promises that it just copies the data, not copies the data, just gives you the possibility to do the zero copy, and this is great. Again, for big arrays, it's a good idea, and then we will also don't want to duplicate the memory if we have the same array, but then more questions. What do we do with unroot? So if we have data read by unroot and put it to Python awkward arrays, who's going to own the data? Is it going to be Julia? Is it going to be Python? Do we want to copy? And for example, if we have data coming from Julia and the user wants to put it to Python and then back to Julia, again, probably we want to have a copy, but so the key aspect is the performance acceleration, because we want the physicists to write these for loops which they are familiar with, or maybe they will just say, okay, we don't want to do the array operations on the arrays, we just want to do the for loop. And Julia does it's really perfectly well. So if we put the awkward array in Julia, we can just write a for loop and it's pretty good performance-wise. Obviously, compared to Python, it takes minutes. And another thing I really liked this Julia multi-threading. And again, more questions for me is that probably not all the libraries are automatically parallelized, and how do we actually design the code and provide the appropriate algorithms to take the full advantage of Julia multi-threading. So again, if we create an awkward array in Julia, we can just push, and you can see that if I have four threads, all the elements, it's going to be not ordered. For me, I was looking at the challenges of integrating of Python and Julia, and I was thinking, okay, so the learning curve and code consistency. How do we actually, apart from learning the new syntax, which is quite easy, and new libraries, because there are a lot of them, and how to choose the best ones, and how to actually teach the best practices, because potentially we can just end up with the inconsistencies in the code base. Dependency management and debugging, we want to actually ensure that actually all the necessary packages are there, and we can debug across languages in easy way. And I think we also discussed sometimes with Uwe and others at lunchtime that actually performance optimizations and updates, we need to ensure that the best practices are in place, and it actually requires expertise for that. Back to the finally to the conclusions that physicists are actually using awkward arrays, and actually the data format is the actually the hardest part is just to convert the data format, because if you go from one language to the other, so to cross the language barrier, and we have this access to the data structures, which actually helps the I think it helps the physicists to adopt Julia, and using PyJulia, PyCall is easier, so we can avoid the costly operations. Obviously, we don't want to do it blindly. We will just check where we need to do the zero copy, where we cannot. And I would welcome suggestions on managing version compatibility dependencies. Let's discuss that, and I would really like your feedback on that. So thank you very much. And finally, thank you, ChatGPT, because actually when I asked, well, is Julia a future language for the future, it said, yeah, with its high performance. Huh? Who paid for this advertisement? Oh, no, I asked who said that. He said, no, it's just like no, it's actually combined the information he had, and it just came with this phrase that with its high performance and flexibility, it's the language of the future. For huh? They, I said, sorry, I should say they.
I think ChatGPT has they, them pronouns, actually.
Yes, exactly. So yes, so thank you very much, and let's talk. And I certainly learned a lot from the workshop, and I would hope to learn even more.